working group chairs. I have a co-chair, Wes, who's not here, and a co-chair, David, who is...
So I'm David Black. I'm another of your hardworking working group chairs, and I guess I get to quickly explain the agenda. So this is the bulk of the agenda: UDP options, SCTP drafts, including the latest on the errata draft, which is now approved and at the RFC editor. Thank you, Spencer. And then we get to do a whole bunch of path MT discovery. Now, on Monday we bashed the agenda, and I want to thank Iju for talking about her draft on Monday, because what's going to happen here is, let's see if I can get this to do its right thing. We're going to pick up the DiffServ to QCI mapping draft at the end of the agenda, time permitting. The items shown on this page are all more important than DiffServ to QCI, and we will put the time into these that we need to get to understand and try to close open issues. All right.
Okay, David, you are going to do the impersonation of Joe, I believe, this time.
I guess that makes me the designated victim, doesn't it?
Well, you have the option of going to the pink box. It's not really an option. Or you're doing slides as well. Okay, I forgot that. The first one.
Send us a slide, we might as well use it.
Okay. So this is David Black presenting a slide on behalf of Joe Touch. Joe's in another part of the world and not able to join us today. Yeah, that's fine. I'll do it. There's only one. There we go.
There it goes. All right. So if you're looking for an update on if you're looking for an overview of what UDP options are, please read the draft. This is the latest update from Joe as an editor. There's a bunch of editing items on this. The first two here, the PLPMTUD and the processing failure items are editing things that are being done to update the draft. Beyond that, we've got a couple of open issues, and then an adventure Gory's going to get to. First is here's what Joe is currently working on for rules for new options that are introduced in the future. You can't depend on the content of the option area. You can't depend on processing order. And the only exception is if for somehow we make a new option mandatory. If options are present at all, this one has to be there. Then you get a little more flexibility in that. Otherwise, it's really kind of rough out there. I'll let you read the bottom of the slide, which is Joe's rationale for what he wants to do. In particular, we don't seem to have a flag that is present in many other situations like this that tells you whether the option is safe to ignore or whether you have to give up and go home if you don't understand what's going on in a particular option. Tom.
Tom Jones. Okay, maybe the discussion answered this question. I don't know how Joe envisions in having mandatory options in the future. So it would require to do a IP style option number space, but there's been no discussion.
We wouldn't, if we were ever to add mandatory options, we get to figure out what a flag day looks like. I'm not quite sure what that line refers to. It might be the case that refers to current mandatory options, not ones to be added in the future.
Okay.
And it's all really complicated because, as I think I saw discussed on the list, if we design a protocol from scratch, and if you don't understand this game over bit, would be a fine thing to add. However, because we're tacking options onto UDP, if you don't understand, then game over is the wrong outcome. It's if you don't understand, then maybe ignore the entire set of options, but don't drop the packet because don't drop the UDP packet because this weird options thing got tagged on and something went wrong with it.
Yeah, but that's really difficult. I think the thing to minute is that Joe needs to come up with a clear direction on this so we can continue.
Yeah, I think so too, and I think I think Joe needs to be in this discussion, as I really can't do a good job of channeling him on this one. So I think that's the update, and I think we have more to come on the list.
There's another implementation update slide deck as well, which kind of follows this. Lars?
Yeah, Lars, I guess I've not really been following this very much, but
That's
is
dangerous.
anybody using this for anything?
Well, there is an implementation
No.
out there.
Is anybody using this for anything?
Well, there is an implementation out there that's nearly finished. So the answer must be no, mustn't it?
Short answer is not yet. It looks incredibly useful for path MTU detection for UDP.
So this seems kind of heavyweight for that. So I don't want to open a rat hole here, right? But I mean, I don't really see anybody jumping up and down for actually needing UDP options. And if that's the use case, right? And given that, you know, I chair Quick, right? And Quick is going to send a whole bunch of UDP traffic. I'd be willing to say good luck trying to get the Quick guys to implement UDP options for path MTU discovery. I think you're going to have a very hard argument there. So
This is not aimed at Quick. If you design a protocol from scratch, you ought to do PMTUD right.
And Lars, this is not the way in which PMTU do it, or PLP MTU. It's a way in which you could carry this with other traffic. Quick will presumably have that mechanism built in, so you would not want to do it.
So since it was brought up for that, right? Yeah. But basically, I think we're building this mechanism which looks incredibly complex and doesn't really. There's one informational reference at the moment for an int area draft that refers to this, right? And I think we're wasting our time.
Input noted.
Should I minute? Sorry, Joe? No.
Hi, Colin Perkins. I have to say I somewhat agree with Lars. You know, the RTP-based applications I know about that use UDP. I can't see what use this is for us. And if it doesn't work for RTP and it doesn't work for Quick, those are the two main uses of UDP. Unless the DNS folks want it.
Not that we know about.
Wait. We're not doing a chartering discussion. We did the chartering discussion. We're not doing a working group last call. So we take these as inputs and we push back on complexity because adding complexity is dangerous with those inputs. But we carry on the discussion, I think, as chairs.
Yes. Speaking of carrying on as discussion, I think it's time for CCO.
Oh, wow. Yeah.
Is this the only room in the box?
No, there are other rooms. Obviously. Yes. CTO's in there.
That's not working.
Just press next.
Okay. I'm Tom Jones. We'll skip that because David did. So we have an implementation for FreeBSD. Presented this in Montreal and in London. It has not materially changed. We convinced Joe to accept the options we need for PLP-MTD, and so they will appear in the draft, but they have been implemented for a long time. We have things we have not implemented, so we'll get to that. And we also have some questions about where the ACS is. The draft is different than we thought it was, so we're a bit confused, but hopefully Joe will respond on the list. Yesterday in MapRG, I presented results on early measurements of UDP options, and we find that UDP options doesn't really work in the internet. It's like a 50% chance on a path that the path will drop UDP options. This slide, which is much harder to read, shows a breakdown of some of the failure modes and what works. The yellow line across is where we are with UDP options, and so we get 45, 50%, depending on the type of traffic we measure, that fails on the internet. If we add the CCO option, which we have a draft for, we get a huge improvement on the number of paths we will work on. The presentation yesterday went into this. So we have the CCO option. Just ensure it has a modified pseudo header, causes a collision in the checksum space, so that if you calculate the checksum correctly or incorrectly, you get the right checksum out. It can't address all of the issues where UDP options doesn't work. And so there's boxes that only allow 0 in the UDP options space. Nothing we can do about that. There are boxes which do a hard check against the IP payload length equaling the UDP length. Can't deal with that. And there's some really weird pseudo header calculations done where I don't know where the numbers came from, and we can't really defeat that. But we do still see a big improvement by using the CCO.
So Tom, can you go back to the slide and show what percentage these things are? Which bits are they? They're the ones that don't work. They're the light blue ones, aren't they? And the dark blue ones, which are tiny parts of this.
Yeah, I can't really read that.
Yeah, okay. So, my slide deck, Tom presenting, but the ones that don't work are the ones above the red and below the gray with the CCO. The gray ones are ones that never work, whatever you set the values to. So these are maybe firewall devices that have rules that don't support UDP options, so or front-end load balancers that explicitly don't do it. So they have to upgrade it as the standards require them to be upgraded and people provide pressure. But for protocol side, it's a very thin sliver that don't work when you have the CCO involved. Sorry, Tom, for the interruption. Go ahead.
Yeah, so we have the CCO. We've had discussion in the past about the checksum, which covers the checksum space and UDP options. The OCS checksum that we have right now is a 8-bit checksum. There is thought that is probably not a great idea, considering the internet checksum is twice the size. For us, the CCO is clearly something which is required to use for most traffic, and so we could move to using the CCO. This could be used as a fixed space in the packet, or we could use it as an option as is. We'd love some discussion on this.
So David Black speaking, individual for a floor, from the floor. There's a time for rough consensus, and there is a time for running code. And after what I saw in MapRG, which was an even blunter version of the more complex chart was shown earlier, I think running code wins this one by a country mile. I would, based on what I've seen and the fact that this makes the UDP options go through a heck of a lot more places than they do without it. I would strongly support as an individual the direction of scrapping the option checksum and using this instead because it works.
So David, would you? Okay, so I think that's good input, and I like that. And there's another question: is do we require this to be present? I think the slide here says that the implementation will use this by default anyway because it's the only way it will work in the current internet. But Joe's point seemed to be on the mailing list that maybe this should be optional because the internet may change completely and we may no longer need this. So should we make this optional or should we make this required?
You left out a third option, double entendre intended.
Yeah.
I believe that a good path forward for this would be to put a should on this and explain what breaks and how badly based on the MapRG results if you ignore the should.
Okay, thanks.
Yeah, and so if we can, that will be the change in our implementation. We will bin we'll bin the OCS and replace it with the CCO. I still like calling it a compensation option. I find that very funny. And then, so on the list this week, I raised some other topics to do with implementation. There are 3 options in this draft that are, one, difficult to understand, difficult to implement, and have very dubious value. The first 2 hit these requirements. So there is a light option in the draft. It involves quite a complicated 4-byte packet swap. We don't have any motivation for this now with the CCO because you need the CCO for UDP options to work, and then you're checksumming your light data, and it doesn't seem to tie together. There is a fragmentation option. I land on the side that fragments are fragile in interior, and I have no interest in implementing this. And then finally, there is an AE option, which is trying to pull in TCP AO style authentication. And I think this is a fine course of action to look into, but it's underspecified in this draft, and it probably needs its own document. And so if we were to continue this, I think it should be a separate piece of work.
So I guess that I'm asking the working group in general, as the working group chair, are people keen to implement these 3 things? If people come running to the mic, if people ask on the mailing list to use this because they think this is useful, or if people volunteer code, even better, then these can appear in the implementation we're working on, and we'd happily add them and check them. If people don't appear at the mic, at least sounding vastly enthusiastic for these, I don't see how these will appear in the code, and therefore we have to make a decision as the working group soon on what to do with these options. Thank you for the cue at the mic. Go ahead, Lars.
Last second. So you're talking about your FreeBSD implementation.
We are at the moment.
Is it upstreamed?
Because it's dependent on whether what the spec is. We have talked about this. Would you like to talk about it, Tom?
Yeah, so I mean, it could be. It's a matter of going through a review.
So
I could commit this.
Which committer has committed to putting this?
Me.
No, you're FreeBSD committer?
Yes.
Okay, good.
And we could, the last conversation I had with Joe is he doesn't want it to be upstreamed until we're in working group last call, because he wants to fiddle, which doesn't really make me very happy.
Okay. Are there other implementations? Sorry, I haven't paid attention to this a lot.
There aren't, no.
Okay.
Hi, Colin Perkins. So again, coming from the point of view of someone who builds media type stuff and does media type applications, everyone arranges the packets such that they fit within the MTU and are not fragmented, and sets don't fragment. So I don't think fragmentation is useful. We have experimented with, so light is partial checksums, right? So we've experimented with that in RTP. I'm sure Magnus, I think, can comment further since he did the draft, but my understanding is that while we did the spec, it turned out not to be desperately useful in practice. And as for authentication and encryption, unless it ties in with stun and ICE and all of that, and the secure RTP mechanisms, I don't see that we would have use for it.
Okay, that's fine. I think the driving force for the 3 options was all from people wanting to do tunnels within the internet that did fragmentation. Yes. So thank you for your input. That was primarily viewed more at the endpoint, and I understand what you're saying.
Yes, I mean, there may well be other applications that have uses for it, but from the community I'm coming from, I don't see them. That doesn't mean there aren't others, of course.
Yeah, that is an important UDP community. Thank you for that input. David?
David Black, speaking of floor as an individual. Fragmentation's a double, has 2 sets of considerations. On the one hand, Tom did mention the internet draft on fragility of fragmentation, and that would discourage the use of it. On the other hand, there are certain tunnel cases in the inter-area tunnels draft where you cannot avoid fragmentation in order to get correct behavior. So I would encourage discussion around fragmentation to perhaps focus on the tunnels case and whether this improves the world when you're sending UDP through a tunnel that is going to have to use fragmentation.
Michael Abramson. So we had quite a lot of discussion on fragmentation, and I mean, it always boils down to it works less well than everything else. And
He said,
okay, yeah. So
I said, I was going to say, yes. The crucial thing to keep in mind is that if you hit tunnel cases where the tunnel has to use fragmentation, and you decide fragmentation is evil, your only alternative is to drop the packet.
Right. But in practice, looking at the wider internet for billions of users and so on, fragmentation it doesn't work very well. So I think I have stated this in numerous emails. We should have networks must support fragmentation, but also that applications should probably try to avoid it if they don't know. If they're talking to anyone and they have no idea. In controlled environments, you can do whatever you want. But if you wanted to work on the wider internet, you'd be better off avoiding it. So I don't know how to handle that. I mean, I want fragmentation to work, but I don't know how to make it work. People put all kinds of weird boxes and weird configuration in their networks, and the result is it works less well.
yeah, and there's no data to show that this would improve the fragmentation case. I spent a chunk of the summer trying to deal with the computational complexity attacks against fragments, and I don't want to keep doing this.
Anything else?
Yeah, so this next. We need to make a decision about the CCO, and we need to find out if the result of the discussion on the list for the ACS was a 32-bit CRCC, and if not, we need to have that conversation again. Yeah, and this is all.
Okay, so hopefully these last 2 points are uncontroversial. That's good. Maybe the previous slide was more controversial. Can we just go back to that for one go? Back. Sorry. That. Oh, no, wait. I wanted to go to the list of things that hadn't been implemented. So we had the discussion at the mic. So the things that haven't been implemented are currently in the spec. The most input I'm asking for the working group is if you're at all interested in this space, please look at the list of things that weren't implemented, excluding ACS and OCS, which Tom says are going to be updated. But the other things, the light, the fragments, and the AO, please comment on whether you think these are important or whether the working group can go forward without them. And please contribute code or examples where you want to use these if you want these to remain at the same level in the spec. We need to get closure on this. We've had it as open as a work item for a while. I don't see increasing activity. I see implementation. If people want to implement as well, please tell us now. And we'll get more input, but we want to close this as a work item by publishing a document, not by it going obsolete. So please look at the list of features. Tell me if you want to commit to review, and please provide feedback on the things that we talked about today.
In addition, we're going to need to run a discussion consensus call on OCS or on the OCS CCO topic on the list. I would ask that everybody please take a look at what Tom presented in MapRG as background for that discussion.
Lars, I could also suggest you rethink whether standards track is really the right standards level for this.
Yeah, Lars, if I said experimental, what would you say?
Well, better, but
So Lars, what is the experiment? Because that's always going to be asked if you have experiments.
so I really as I said, right, I don't see anybody really needing this, right? I apologies, but I don't see anybody also really sort of super interested in implementing it. Because that's the other thing that drives it.
Yeah.
Drives adoption, right? If it's in the stack, somebody might use it, or it gets into the stack because we really want it. So I'm really sort of, and then I haven't really followed the MapRG discussion yesterday too, but it seems like this is making UDP more fragile, even with CCO, right? It still increases. You're not at 100% delivery rate.
You don't get 100% delivery rate because there are boxes out there which police, which...
Correct. And so I mean, we had a discussion in Quick where Quick doesn't work over some small fraction of paths, right? And
it's the same 5%, by the way.
right. So if you're an UDP application, right, and you basically can use this and give up 5% of your delivery chances, or not use this and have 100% delivery or whatever you have, right? So it seems like the incentives for actually using this seem to be pretty. Yeah, it got worse. Even with so it was really bad without the option, and then with the option added in, it was better, but it was still not at baseline delivery, right?
It's still not 100% because there are boxes out there which discard no matter what you do if you add anything.
Right, and so. You know, it seems a pretty hard sell for somebody to say, well, you know, I wouldn't just do this in UDP inside my application rather than running it as a service. Go ahead.
Yeah, cool. And just because you're using UDP option doesn't mean you use it on every packet. And UDP is an unreliable protocol. So I'm actually, whatever use case you have, that might not impact you.
Yeah, maybe we should move on because I mean, you could probe to see if UDP options were supported, and you would get this. You'll be then no, which if you don't use it on every packet is a perfectly viable thing to do. We should talk about this on the list. This is a good topic on the list. Mira, you call.
Yeah, but I'm also tending towards experimental because I mean, like in the transport area, we have been more strict about this than in other areas, so whatever. But it would be nice to have actually real deployment experience with that, and not only one single implementation.
So we're experimental because we require more than one implementation. We need, yeah, is that what you're saying?
No, some deployment experience.
Because we need deployment experience. Okay, we need to talk about this on the list. It's fine.
So there's, I mean, if the transport area wants to say, you know, this is a mechanism and we believe people should be using it, then you should be, you know, telling us what it's useful for, and I frankly don't hear that, right? And so if you're building a mechanism and we don't know what it's useful for, why are we building it?
Please take that to the list.
Hi, Colin Huggins. So you know, I'm unconvinced that there will be much use for this, but I don't see that there's an experiment here, right? It's well defined. It does what it says it does. It may or may not be deployed, but that's true of many protrols. So
Yeah, I think it needs to go to the list. The experiment may,
for standards track.
the experiment may be, is it useful in practice? Are people actually going to do anything with it?
But that's not really an experiment. That's do people care enough to deploy it? And we have lots of standards which people, you know, didn't care enough to deploy in practice.
The comment from Fred here is that was unfortunately very good segue to the SCTP topic.
SCTP. This slide deck's from Michael Tuxen, and we're going to talk about the network address translation support. This work was on hold until the RFC errata was published. That's now with the RFC editor, so this work will start. There was significant review in the last call, and in preparing for the last call is what I meant. And most of this is to do with taking this document that's been around the working group for quite a while, which has been edited in various places, but was being prepared for working group last call. I did a working group Shepherd review, Gary First is me, and I suggested organization improvements to try and make this more readable by people who were doing middle boxes as well as SCTP maintainers. There were other comments received since that document was commented on, and the intention of the authors is to prepare a new version that we can actually send to the TSVWG list in preparation for that working group last call. If you have looked at this and you feel that there are opinions on NAT support for SCTP, please be aware that now is a good time to comment on this draft as we head towards the working group last call. That was it. It's even quicker. There should be a drum roll. We published the errata document. The errata document was subject to quite a lot of debate by the IESG in terms of process. The errata document was a plan by this working group to follow the practice they've done with the previous revision of SCTP and identify all the things that have changed in the SCTP spec from 4960. This document is now with RFC editor, and the plan is now for the working group to open a replacement document for 4960. The first version of the draft will be a copy of 4960 mangled by the IETF tools to regenerate a XML file or an editable file so we can actually start with a 00 draft which reflects 4960 as much as possible. Shortly after that, 4960 bis will be rolled again to produce 01, which will be a committed set of changes from all the ones currently identified in the errata. No other changes will be intended. Then version 2 will appear, which starts to include the text clarifications to the SCTP spec. I'm going through this process to try and be clear because the intention of this process is to implement the errata document we specified and the textual improvements so that this document is a better specification of the protocol. If people know of other changes apart from errata, then they should be, of course, discussed here. If the implementers know of any other things that need to be changed, please discuss them. But the current intention of the working group in opening this is to just provide textual improvements. We've done this with other IETF documents. I worked with the PIM SM new spec, which was simply a rewrite of the spec to make it better and clearer, but didn't change the protocol on the wire in any single way. This may well be the way forward for this particular document. Because this is purely improving the shoulds and musts and the way things are described and presented, we expect this to be very fast through this working group. We shall see how quickly and easily we can provide those textual changes. Spencer, you're near the mic. There are process things involved with all this. Would you like to comment on them or anything else?
Spencer Dawkins, responsible outgoing area director. I want to thank you for putting this slide up and kind of explaining the multi-step process. Actually, I think it's really good for us to start out with something really close to nothing for the 00 draft of Abyss, and I think that's something that would be good if we did more. Because you invoked the name of the errata draft, I would say that the ISG has an action item, and not just for that draft, or not even just for that draft plus that use case draft, but for other drafts going forward on what our plan is really. But thank you all for not freaking out when you saw how many abstains are there? I didn't count them. I mean, once it goes to 2 rows in the data tracker, I really don't care. But like I said, basically you all were part of the ISG figuring out that the ISG had something that they needed to talk about, and I think that's going to be really good for the ISG and for the IETF. So like I say, I thank you all for doing the right thing as best you could and helping us do the right thing as best we could. And I think, I'm not neither Miriam nor I believe, are the area director that is responsible for the action to figure out what the right thing is, but one area director is. So thank you all for that.
Thank you, Spencer, for taking us through the experimental IESG process. I'm done.
Datagram, packetization layer, path, MTU discovery. So in Montreal last time, we promised some pretty large changes just to the structure of the draft. We promised we would break down into more of the core components. And so since Montreal, we have done all of this. And so we have renamed the phases, dealt with transitions in the state machine, redrawn diagrams, consistently renamed terms so they are correct, we hope, clarified states, clarified suspending the algorithm, verified normative text, clarified terms throughout the draft, and added a security consideration section. And so now the draft is different than it was before, and so we now introduce the mechanisms to implement DPLP M2D. And so the way the draft is structured now, it should be relatively easy to point into the draft if you need to from somewhere else. So you can say, this is how we should, this is the requirements of how we should do probing, and this is what black hole detection is and how we should address it. Here are actually sensible rules for PTB handling, and we broke out the error states. And now when you read through the draft and you consider the algorithm is broken down into 4 major phases, where we confirm the path, search, complete our search, and we end up in an error condition. And so to introduce this, we have a simpler state machine as in addition to the overall giant machine, which is hard to get into a single page of IETF ASCII art. And so this gives you enough pieces so that you can look at the algorithm in isolation and you can figure out what the processes you need to do DPLP M2D. So at the end of the slides in Montreal, we added that we were going to talk about robustness and error as continuing pieces of work. And so we've now added more text on robustness. Robustness is where we have the algorithm deal with paths which struggle to sustain a base MTU. And the base MTU for IPv6 is 1280, and for IPv4, it's a number like 1200. And so we have defined error states, and so the algorithm can move into an error condition if the path doesn't support the base MTU, and then the application can make a decision about what it actually needs to do. So the layer using this algorithm, at the point where we cannot actually find a good number, you can decide if you're just going to keep looking, if you're just going to use the path anyway, or maybe you want to break down and use IP fragmentation. We hope not. And we also added text on resilience to inconsistent paths. This is the situation where maybe you're getting occasional routing across different paths and you get different values. And so we want the algorithm to be able to try and detect this so that we can try and pick a consistent state that will work. Yeah, and this is still an open area and we still need to do a bit more work here. Implementation, so we have a new implementation at University of Aberdeen. We've been running this in a lab, and now we're starting to do real-world testing between ourselves and cloud providers. We got comments on the list from Christian on integration with Quick. I haven't managed to speak to him to find out if he has an implementation. Most of his comments were nits and issues with just pointing to the right parts of Quick in the right frames. And I think now that takes us up to 5 implementations of this, 2 of which I didn't do. And so I think we're actually in quite a good place in terms of implementations. We'd love to hear about other people with implementations of this, just so that we can be more sure that the algorithm is sensible and that the draft is readable and you can pull the right information out of it.
on clarification, when you say you propose text for quick, you mean this week?
Yeah, so we're gonna propose text for quick transport. Gori and I need to sit down. I have a one-word diff, but I think maybe he wants a longer diff. But we'll see. And so we think the draft is in good shape. We think it is quite stable.
Michael Abramson, so has this been in like V6 ops and any other play? There are not so many people like me moving packets in this room. So I'm wondering a little bit if we should ping some other people about this, the next steps.
I think that's kind of where this slide leads to. We will have some people from 6man here who also do PathMTU discovery, or think they can. And we'll talk about that in a second, just to try and widen that scope in the way you suggest. I think a greater number of eyes on this now would be really good.
Yeah, and I think not only 6man, but also a bit more of the operational community would be a good thing.
Excellent. Please help do that.
Yes, I will. So actually, I think it just struck me. I should probably go to like the NANOG list and something and point to some of these efforts, because I think that there are some people that don't even follow the IETF that might be interested in this. There are these people. No.
Jelinko, second in this, because last RIPE meeting, I was given update on what's happening in V6 area. And when I mentioned PathMTU discovery thing, people run to the microphone saying fixing PathMTU discovery, it's like believing in Santa Claus.
Yo, that's exciting. Thank you.
Yes, I was really excited, yeah, because I still believe, and I was upset to hear it doesn't exist. So yeah, I do believe we need to stay in touch with operational people who like might be slightly afraid of IETF.
Excellent. Thank you. Being Santa Claus would be lovely.
Are we too late in the week for V6 ops? I don't know when it is.
Yeah, it's fine.
But
We
I
can
mean,
talk to these people.
Yeah, I mean, also just pinging them on the list, asking the chair to send out an email or something. I didn't mean like actually go there and be in the session, but just posting something on this list.
Yeah, Jelinko again. Speaking of V6 and operational community, at least for example in Europe there is RIPE, and as with my V6 working group RIPE co-chair hats on, you are welcome to come and present.
Thank you.
Okay. Yeah, and so mostly speak to other people, I guess, is where we need to go. And we do need more experience with the robustness and resilience mechanisms in the real world. We're hoping to get that in the next few months, where we run this for a while. Yeah, this is all.
Okay, any questions on the document? Please read. We'll reach the stage where we think the document is right, but we want to get more experience of this. But there's also possibilities for more help from the layer below. So let's hear what's going on in 6man to see if that helps us.
Right, so this, I guess, is for the people who believe in Santa Claus. Consider this a liaison statement from the internet era. So we've been looking at...
Oh, please don't use that L word.
So we've been doing PMTUD for 30 years, or trying to do it, and there has been a few proposals for, at least some thinking about, clean slate. Could we do PMTUD better at the internet layer? So the problems we have with the current mechanism, which is the ICMP-based packet-to-big that we have today, it's throttled in routers. So that's a defined behavior in the RFC. So routers are supposed to throttle these messages. It's filtered in firewalls, ignored by hosts. In V4, you didn't even get enough information in the ICMP packet to match it with the flow you were sending. Doesn't work well with load balancers. Requires multiple round trips, and detects destination. Per destination of the flow. Do you already have a question?
No, I don't have a question. I just want to say the same thing I told you yesterday, because you haven't updated your slides. I just want to add that there. This is not an exhaustive list. There are like five or 10 different ways. This is basically like ICMP is filtered in firewalls. That implies like someone did this on purpose. There are so many times where there's just a misconfiguration that this happens. So this is not just malice,
And it
this is incompetence.
Also fails on the layer 2 networks. Switches might silently drop large packets. And we have been doing this for a while, right? I think 1063 came out in 88, so we're 30 years in here. And what are the options? What's the solution space here? And we wanted to just see what are the possibilities here. And clearly there are work in other areas. So the routing area is doing this in routing protocols. Well, you can just advertise the MTU in the routing protocol and be done with it. That's being done largely, it seems, for segment routing. I haven't studied this work very much. If anyone is familiar with it and it's good, let me know. Multicast area is doing stuff specifically for beer. And of course, we're here in transport, which has to do it. I mean, we're not saying that we can do this solely in the internet area, right? But the goals we have is, it has to be robust. It has to be deployable. That's probably the hardest one. It would be nice if we could detect the path MTU in a single RTT, and we shouldn't make the signaling traffic, signaling back to the sender an easy target for filtering. We also have a unique set of problems of trying to have a heterogeneous MTU on a single data link, which the current methods don't support. And when we talk about these solutions, think about detecting the MTU different from signaling the MTU back to the sender. And we could signal back in different ways. You could use an UDP option. You could use the existing ICMP packet to big message, which is, well, it doesn't sound like it's that more prone to dropping than if you had a UDP option, but that's not my problem. It's on a different layer. You could use an UL3 option, or like an extension header, or you could do it in the application. So punt to transport, that's the default. You guys, it's your problem, not mine. And that's essentially, you have the final responsibility for the path MTU, right? So you have to do this anyway, and you have to do it for a long time. Even if we came up with a mechanism in an internet layer that could guarantee you to find the MTU, it would not be deployed in one day, right? So this is really your problem. We're just here to help, So the second way of this, we'll just leave status quo as it is. We could do in-path fragmentation, right? We've done that before. That was supposed to raise a chuckle. It did in 6-man. And we could just ignore, stop doing. We could just have a fixed MTU, fixed cell size, 1280. Or we could do, there's 2 new proposals in 6-man. One is doing packet truncation. So the sender sends a packet as large as the outgoing interface MTU. Intermediate routers truncate the packet, if it hits an outgoing interface with a smaller MTU, and sets, a truncated flag. The sender sets a truncation eligible flag. Probably have to record the original payload MTU if you were to do this on normal data packets as opposed to probes. But you could imagine a way of doing this where you could pad out a TCP SYN, for example, get that truncated, and then in the SYN-ACK it would do the same thing, and you could discover the MTU on a single RTT. We require all the senders, receivers, and intermediate nodes to be updated and support this, of course. So Ron Bonica has a proposal for this, and he has some ways of making this look backwards compatible. So this thing, since it sends large packets, wouldn't necessarily detect, L2 switches, which would silently discard large frames, for example. So that is one solution proposed. The other one is path MTU recording, which would be that you send a small packet with an IPv6 hop-by-hop header option, where the intermediate node would then fill in the MTU if it was, the outgoing interface MTU was smaller than what was already in the packet, and you would then achieve the same thing by discovering the MTU in a single RTT. Mechanism doesn't prohibit or state anything about how the MTU is sent back to the sender. That could be, the same, L3 option, or it could be done in L4 or L7. And you could piggyback this on data traffic, or you could use a separate probe, just like if you do with truncation. And we have not concluded. This is just playing with ideas at this point. And I think we really want feedback from you guys if it's worth spending any cycles in the internet area trying to do this, because it's clearly, getting any of this deployed is certainly a big challenge. Please, Spencer.
Tom Jones. So I have a bias because I did the last presentation. I think no matter what you do, the transport is going to have to deal with this. Your solution to do nothing is the same as leaving it to the transport.
Yeah. No, and as I said, transport, this is just helping you. It's just giving you hints and trying to help you. We're not going to solve it for you.
Yeah, and I think from the perspective of the transport, the service offered by the network is 1280. The network can't offer a higher service, and so maybe just leave it to the transport to try and use more, and actually let us send packets larger than 1280. I mean, if our operating system has an MTU estimate and it's bound into the route, it stops us sending packets, and it makes it impossible for us to search without clearing that state out. And so maybe we take this responsibility from the network entirely and we give it to the transport.
Would you be happy if my routers now just silently discarded packets that were too large? Did nothing else, just discarded them?
Isn't that what they already do?
Well, there's sometimes, if you can be bothered, send an ICMP message back.
Yeah, but the ICMP messages are, they're very fragile on the network, and they don't give us great information. They give us a really inconsistent signal. In our draft, we still have to probe when we get that number, so it's not like it solves a problem very quickly for us.
Yeah. So this should really be deprecating RFC 8201 and 1981.
I'm starting to become a big fan of deprecating RFCs.
Cool. Yeah, I can do less work. I'm happy with that.
Spencer Dawkins, and I'm doing this as responsible area director for TSVWG. I wanted to thank you for being here, number one, because I think that a lot of the work that we're going to have to be doing going forward in general at the IETF is going to be like what you're talking, the conversation you're having here and in other places. And I wanted to thank you for coming here and doing that. I wanted to, unless somebody lines up, a bunch of people line up behind me telling you, no, don't do this, it's a bad idea. I would encourage you all to spend cycles on this. This was a, is it 8201? What was the RFC number?
Yeah, the 8201 is
yeah. So when we
yeah.
took it to full standard,
Yeah.
there was an awful lot of heartburn about, this isn't actually usable now,
Yeah.
and that isn't going to get any better. And the MTUs aren't going to get any smaller, it seems to me. So, for you all to be working on it, yes, and for you all to be working on it with other people and, communicating and cooperating the way you're doing, seems like to me exactly the right way for the internet going forward. And I say I just really appreciate that. And I guess the other thing that's worth saying is, if step 2 is to deprecate something, step 1 should not be elevating it to full standard. So just file that away in case it ever comes up again.
Just a minute, Gary first, and just inserting a little bit of a process in here. We're not actually talking about deprecating this, in case anyone's remotely listening. We're talking about how we use these signals and really how useful they are. There's some discussion opening here, and I'd welcome people to discuss it and see where it all ends up. But if we do it all together, I think it must be better. Following that, more people at the mic.
Bob Hinden, and this is sort of back to Spencer. So regarding deprecating 8201, so the mechanism we're proposing to use in these new things is also sending packet to big messages. So what we're changing is that the destination host sends them instead of the intermediary. So it's not that's still the mechanism that we are currently using. I mean, we could do something new perhaps, but so it's not.
But I think the point was, is there anything we can do on the internet layer that has any value for transport? And I think John said, well, I perhaps don't think so. And
yeah, and just to follow up, I think the part of the slide up that was up there saying you may get this information in a variety of ways. I think that was kind of a interesting observation, because right now it's like, well, either we're gonna what you get is this, and if you don't do this and you don't have path MTU packetization layer, path MTU discovery, it just kind of sucks to be you, and so we're having these interesting conversations, which we're seeing for UDP and stuff like that. I mean, it's like it's a real problem. So like I say, I probably the only people that responded the way I did to the comment about deprecating were probably all validated on that document during ISG review, so you're safe. But I say, you're kind of talking about convincing people that something matters, and the best way to convince somebody that something matters is that we not just dumping everything on you, but that we come up with something that works and it is useful. Because I think there's a lot we could do. If we really knew that we could know in a reliable way what path MTUs look like. So almost all the time, which I don't think that's true right now. And I'd like for the internet to be that way. Thank you.
Okay, we can cut the mic line now. We'd like to squeeze one last presentation in down at the end if possible.
Igor Lubashev. So it just looks like I want to add to the enthusiasm from Spencer and from Bob. It seems absolutely clear that transport will have to do PMTU discovery, but it seems to me also very clear that if a network can provide a service to do it faster, even in 50% of the times, and more reliably, then it's actually a big benefit for the internet.
Okay.
Michael Abrahamson. So I would just, but moving packets will try to do a better job in providing the signal back. I think but I would also like to point out that was not here, is that what's probably even better working in today's internet is TCP MSS clamping. And that is a network signal. And I know a lot of people hate it. Just want to point it out. We have a way of setting in a packet for that's, please don't use larger packets than that. I know everybody hates it, but it is a signal. It's widely used. And if we just made that not work tomorrow without PLMTD, I can assure you, you will not want to use your internet in a lot of places. It will not work.
And if you don't use TCP, then be aware that many networks work because of MSS clamping.
Yes, because I've had that discussion many, many, many times. Path MTU discovery doesn't work. We'll just do a TCP MSS clamping. This is operator reality. You might hate it. I hate it. It's reality.
So there is some ongoing discussion about this, and there are some people meeting around the IETF space. On Friday, see the mailing list for a note about where people are meeting or who to talk to. Please continue this, because if the PLP-MTUD is reaching its end here, we're in the final stages of discussing all the corner bits. Now is a good time to discuss how we use network layer signals.
And that side meeting that's advertised in this mailing list and on 6man, I think. It might be worth sending to the int area as well, perhaps.
Okay, we want to squeeze one last talk in because we have the opportunity to do a heads-up talk of something that we've spoken about in the past. That's the relationship between diffserv and the QCI. This is a mapping draft for diffserv. It's the first cut at this, but it's an area that probably requires a lot more people to look at it and make comments. So please guide us through quickly the highlights of your draft, please.
Thank you, Jerome Henry. So the first draft you have here in the server, the PowerPoint, which is a summary of what the text is about. Yes, these slides. Actually, you have 55 slides here if you have nothing, to read during lunch. So what this is about is in the LTE world, 3GPP world, there is a QoS mechanism. There are several of them. One of them is called QCI. It's been only mildly used over the years for many reasons. One of them is that it's a control medium. But what we see is that we have more and more requests to be able to align the intent of QCI with the intent of the served domain. And that comes in many scenarios where either your station, the UE here, has multiple connections and multiple links are running at the same time for the same application. And that's, thanks to QUIC and PTCP and some other mechanisms, or because your UE is going to alternate between the two connections, or because it's going to talk to a station which is in the other domain. The LTE 3GPP people have done a lot of work over the last few years to increase the number of QCIs. They initially had only 4. Then they climbed up to 9. They were at 17 last year, and now they have 21. And those QCIs are expressing intent which are different from what we do in DiffServ because they express intent not only based on the marking, but also on the priority level based on requirements of the specific application. So if we have this scenario where that station is going to have to communicate over the two mediums at the same time, we've been more and more asked about a mechanism to translate the intent of these QCIs into the server intents. And also at the same time, if your application is marking the server a certain way, and you get into the P gateway, which is the interface into the 3GPP domain, how would you translate the server intent into something that makes sense into their domain? So this draft is the first attempt to do that, trying to create mechanisms. And we found, unfortunately, that just using RFC 4594 and a few others just didn't work. We have to create new values here. So this is the first attempt. I would like to encourage you to read it, provide feedback, write to the mailing list, ask questions about what these are if they are not something you're familiar with, because there will really be a need for us to create a mapping that works in both directions.
Magnus Westlund. What's the relation to the 3GPP work, and why is 3GPP not doing this themselves?
Yeah, that's a very, very interesting question. And how long do you have for the answer? Would be my answer. So, in a nutshell, they're working inside their domain, and there's actually a work done not by the 3GPP because they're concerned to the UTRAN, right? The 3GPP world, not the outside world, but the GSMA has done a mapping that was done maybe 15 years ago, but that only addresses the 4 queues that were of interest for them. So now that 5G is raising the speed at which those QCIs are going to be created, there will probably be a work at the GSMA, but I think it's more on our side, the serve people to create that mapping rather than the GSMA.
That sounds a little bit, as this 3GPP defines the QCIs and then the intention, I don't find it unreasonable that they actually also say, okay, this probably maps best to these per hop behaviors. So I just feel that maybe at least we should at least have a handshaking in the relevant 3GPP working group about this, and maybe GSMA also. But that's, if we're gonna do this, I would like to know that they are okay with it rather than be stepping on their toes.
Oh, yeah. I think that's I'll answer for that one. There's a prerequisite here that this is a 0.0 draft, although it's got a huge amount of text behind it. It's the first time it's been aired at the IETF. We are not going to do this work on our own. It may be a great thing for the IETF to do if other people think it's a great thing to do as well. So let's talk about this and let's tread carefully.
Okay, Jidong from Huawei. Yeah, actually for the QCI to the DSCP mapping in LTE, the BBF Broadband Forum, they have a standard which define or describe this mapping. It's called TR203. I think maybe that can be referenced here.
Okay, we cut you a little bit short because it was a heads-up talk, and yes, we want to take more comment on that.
Okay, and Jahed here. I'd like to kind of like emphasize what Magnus has said. Like, I mean, I read through this draft, it is good written, but I didn't find references to the problem we're trying to solve here. That is like what's happening in the 3GPP. And if they don't say like, I mean, you can define all this mapping here and expect like the eNodeB, PDN get will that's the like recommendation, right? Our behavior recommendation. Let's hope that will match. But if they are not doing it, and as I see the mapping, they have like QCI mapped to multiple, DeepServe kind of code, one QCI. So if they are not agreeing what we're doing here, it's just like, I'm not sure like it's the right way to do it. So a collaboration and mentioning what's happened and why that is not working would be nice to actually hear.
So are you volunteering to help do that?
No, I'm not volunteering to help there.
Okay, so we are still at the place where probably we need to bring this work before more eyes at the IETF. And we need to keep an eye on what other people are doing outside of the IETF. And these two parts of the puzzle have to be brought together before anything will progress here.
Absolutely agree. And just a conclusion on that note, the 3GPP's charter is not to define deep serve marking, but we're definitely engaging them because they work in the 3GPP domain, but we are engaging them. And I think we need to continue discussing with them.
This reminds me somewhat of the work we did on Wi-Fi mapping, and just as was the case for 802.11, it's going to be necessary to educate this community on what QCIs are and aren't, and what the state of the art is, both in spec and deployment, as a foundation to look at how the mapping comes out.
So finally on this topic, please discuss on the list, not necessarily the proposal, but the whole concept of what could be done here, what should be done here, and what is being done elsewhere. And hopefully we'll be able to progress on the topic to know whether we have insight and help here. Use the list, please. Thank you for coming to TSVWG. Have we reached the end of our slot? Thank you ever so much. See you at the next meeting. Please use the list in between. We have lots to talk to on the list. Blue sheet.